Hello, good day. How are you today? You're good, right? Okay. Are you ready for today's lesson? You are? That is good. Today in mathematics, we are going to be looking at data and statistics. Okay? Our topic for today in mathematics is on data and statistics. Are we ready for the lesson? We're going to be looking at statistical questions, histogram, mean, median, mode, mean absolute deviation, and probability. Okay, so first we are going to be looking at statistic questions. Okay, what are statistic questions? They are those that can be answered by collecting and analyzing data. Okay, statistical questions are those that can be answered by collecting and analyzing data. And examples of these questions are: how tall are the students in your class? What is the favorite color of students in your school? How much time do students spend on homework each night? There are different questions you can ask and collect data on it, analyze them, okay? Do you understand? These questions involve variability and are open-ended, encouraging the collection of diverse data. Okay? So we now know some few statistical questions. There are more. You can form your own question to ask. Okay, do you understand? It's just for the purpose of collecting data and analyzing that data, okay? So what do we know about histogram? This is a histogram. It looks like a bar chart, right? But this is called a histogram. A histogram is a graphical representation of the distribution of data sets. It consists of bars that represent different ranges or bins of data, and the height of each bar corresponds to the frequency of data in that bin. Okay, so this is called the histogram. It looks like bar graph, but this isn't bar graph. Bar graph, the bars have space in between, right? But here in histogram, the bars are joined together, okay? That's the difference between bar graph and histogram. Do you understand? Here represents the frequency, and this place represents the ranges, okay? So we can now differentiate between the bar graph and histogram, right? Good. So you can also use the histogram to represent your data set, okay? So now we're going to be looking at mean, median, and mode, okay? Are we ready? We're going to be looking at median, mean, and mode. Median. Median is the middle value of a data set when it's arranged in numerical order, when it's arranged in ascending order, okay? And mean is the average, the sum of all values divided by the number of values. And mode is the value that appears most frequently in a data set. So we're going to be looking at examples on median, mean, and mode, okay? Median is the middle value of a data set, mean is the average, and mode is the most occurred or most frequently appeared in a data set, okay? Here we have find the median, mean, and mode of this data set. We have 12, 17, 20, 15, 22. The first step, you arrange in ascending order, okay? The first step, you arrange in ascending order. So the smallest number here is 12. You start with 12. The next is 15. The next is 17. The next is 20. And the next is 22. So this is arranged in ascending order. What do we do next? We are going to find the median first. Now the median is the middle number. How many numbers do we have here? 1, 2, 3, 4, 5. So there's a middle number, and the middle number is 17. There are 2 this way and 2 this way, but there's 1 in the middle. So the middle number is 17. The median is 17, okay? Now the mean, how do we find the mean? The mean is the sum of all values divided by the number of values. That is the sum of all these numbers divided by the amount of number here. So we are going to add all these numbers together, okay? Divided by 5. There are 5 numbers here. So 12 plus 15 plus 17 plus 20 plus 22 over 5, okay? When you add all these values together, you are going to have 86 over 5. 86 over 5, okay? Did you get that? So 86 divided by 5 is going to give you 17.2. You can confirm using the long division method, which we have learned before, okay? You are going to have 17.2. Now to get the mode, we are going to be looking at our values, our data set, to see which number appeared more. Now there is no mode here because no number appeared more. Each number appeared once. So no mode in this data set, okay? Do you understand? Good. Let's look at another example. Find the median, mean, and mode of this data set 8, 14, 16, 14, 12, and 10. First, what do? You arrange in ascending order. You start from the smallest to the biggest. So 8, 10, 12, 12, 14, 16. Have you arranged those? Good. Now we look for the median. How many numbers do we have here? 1, 2, 3, 4, 5, 6. We have 6 numbers. 6 is an even number, so the middle numbers will be 2. Okay? So 12 and 12 is the middle number, okay? There are 2 numbers before this first 12, and there are 2 numbers before the second 12. If we take 3 at this side, take 3 at this side, there's nothing. So this is the middle of this set, okay? 12 plus 12. Now we have 2 middle numbers. So we are going to add them and divide them by 2. That is how you get the median, okay? If you have 2 numbers as the median, you add them together and divide it by 2. So 12 plus 12 is going to give you 24. 24 divided by 2 is going to give you 12. Okay? We have gotten the median now. We are going to get the mean next. The mean is what? The sum of all the value divided by the number of the values, right? So we add all these numbers together divided by 6. We have 6 numbers here, right? So we add all the numbers together and divide it by 6. When you add 8 plus 10 plus 12 plus 12 plus 14 plus 16, is going to give you 72 divided by 6. 72 divided by 6 is going to give you 12. So the mean is 12, okay? Now to get the mode, we are going to be looking at our data set to see which number appeared more frequently. And here we have 12. 12 appeared twice. So 12 is the mode, okay? Because 12 appeared twice. Others appeared once. If 14 appeared 3 times, 14 would have been the mode. But here 12 is the mode because it appeared twice, okay? Do you understand? I hope you are not confused. Okay, so next we are going to be looking at mean absolute deviation, okay? Mean absolute deviation measures the average distance between each data point and the mean, okay? Calculating it by find the absolute difference between each data point and the mean, then find the average of those absolute differences, okay? So we're going to be looking at an example to help us understand this better. Number 1, we have find the absolute difference in this data set 10, 15, 20, 25, 30. So first we are going to look for the mean. And how do we solve for the mean? You remember, you add all the values together divided by the amount of values, right? The number of values. So you add 10 plus 15 plus 20 plus 25 plus 30 over 5. We have 5 values here. 1, 2, 3, 4, 5. So when you add them together, it's going to give you 100 over 5. 100 divided by 5 is going to give you 20. Okay? So now to get the absolute difference in this data set, to get the average distance between these data sets, okay, these data points, each data point, you subtract it from 20, okay, to get the absolute difference. So the absolute difference is 10 minus 20. 10 minus 20 is going to give us minus 10, right? But here we have this absolute symbol, means it should be positive, okay? Any negative number should be positive. So we have 10 minus 20. It's going to give us minus 10, but since we're looking for the absolute difference, meaning it should be positive, we take 10 as the answer, okay? 15 minus 20 is going to give us minus 5, but we're looking for the absolute difference. We take 5, not minus 5. 20 minus 20 is going to give us 0. 25 minus 20 is going to give us 5. 30 minus 20 is going to give us 10. So the mean absolute deviation is equals to 10 plus 5 plus 0 plus 5 plus 10, okay, divided by 5. Do you understand what we did? We have gotten our mean, which is 20. Each of these data sets, we are going to subtract it from 20, the mean, to get the absolute difference, okay? And this symbol here represents the absolute difference, meaning if there is a negative answer, it should be positive. So here 10 minus 20, which will give us negative 10, we have it as positive because of the absolute difference, okay? So we have 10 here. 15 minus 20, which is going to give us minus 5, because of the absolute difference, we have 5. 20 minus 20 is 0. 25 minus 20 is 5. 30 minus 20 is 10 over the amount of number, okay, which is 5. We have 5 data sets here, so which is 5. So when you add all these numbers together, you are going to have 30 over 5. 30 divided by 5 is going to give you 6. So the mean absolute deviation of this data set is 6. Okay? Do you understand that? I hope you're not confused. Good. Next, we are to look for, find the absolute difference in this data set 5, 8, 15, 20, 22. Remember the process we did? We will first of all look for the mean. And looking for the mean, you add all these numbers together. When you add them together, you divide them by the amount of numbers, right? So 5 plus 8 plus 15 plus 20 plus 22 over 5. When you add all these together, you are going to have 70 over 5. 70 divided by 5 is going to give you 14. So now we have gotten our mean. So each of those value which we have here, we are going to subtract it with the mean to get our absolute difference. So we have 5 minus 14, which is going to give us minus 9. Since we are looking for the absolute difference, that means it should be positive. We have 9. 8 minus 14, which is going to give us minus 6. We're looking for the positive difference, okay? So we have 6. 15 minus 14 is going to give us 1. 20 minus 14 is going to give us 6. 22 minus 14 is going to give us 8. So you add all these together divided by 5 because we have 5 values here. Okay? So 9 plus 6 plus 1 plus 6 plus 8 divided by 5. When you add all this together, you're going to have 30 over 5. 30 divided by 5 is going to give us what? 6. So the mean absolute deviation for this data set is 6. Okay? Do you understand? I hope you're not confused. Okay, good. So next we're going to be looking at probability. What do we mean by probability? Probability is the likelihood of an event occurring, okay? Do you understand that?